In Part 1 of Lecture 2, we will answer the question, what is lexical analysis? Lexical analysis is frequently referred to as scanning, and may even be better known by that name. It's the process by which a stream of characters that are coming in without any relationship already established with the other characters before and after are grouped into character strings that can represent the words of language, known as lexemes. These lexemes may also represent other elements of the program, such as operators or numbers. Tokens, in turn, are the basic building blocks of the language's grammatical structure. They are representations of the particular element in that grammar that the strings that we read comprise. These basic elements can be identifiers, they can be literals of one form or another, or specifically they may be reserved or keywords in a language, or the operators in the language. The difference between lexemes and tokens cannot be overemphasized. Lexemes are the strings of characters assembled as we read the program character by character. The token is an indication or a representation of the element of the grammar that this string represents. To give you an example, let's say I declared a variable average. The lexeme would be the sequence of characters A, V, E, R, A, G, E. Whereas some representation of identifier would be the token for this. The diagram shows scanner in terms of its relationship with the other modules within the front end of the compiler. It is also a module in and of itself that interacts regularly with the parser and also the symbol table. When the parser requests a token, the scanner will then read more characters from the program, and after it completes a lexeme, it then saves the value in the symbol table, unless it's already there, and returns the corresponding token to the parser. Again, we know that the parser is the driving force for much of the compiler's front end. It is the one that calls for tokens from the scanner. It will also look at the semantic actions when it needs one and have that carried out. And again, like every other part of the front end of a compiler, it adds information into the symbol table, as well as occasionally getting information from it. Let's take a look at another example. Here you can see that we have the statement for I equals 0, I is less than amount, I plus plus, and in that case we will add x sub I to the sum. Now let's take a look at the stream of characters that we have for this. And you'll see also below it the ASCII codes for these characters. F, O, R, and blank. That tells us that the first word is for. For, being a reserved word, has a one-to-one relationship with the token for. After that we have an open parenthesis with a letter afterwards, so the open parenthesis is a lexeme in and of itself, corresponding to its own token, open parenthesis. We then have an I followed by a blank, so I is our next lexeme. And given that it is user-defined, it has the token identifier. We then have an equal sign, which is the assignment operator, and literal, the value 0. We then have a semicolon, which also has its own token. We have I again, so this time we know already that the token is identifier. Less than, being an operator, has its own token. Amount, which is also an identifier. A semicolon, and so on. There are many instances where there is a one-to-one correspondence between lexemes and their respective tokens. This is usually the case with reserved words or operators. When the user defines identifiers within the program, these will typically all have the token identifier. Numbers that appear in a program are typically assigned the token literal, or they may be given something more specific, such as integer literal. Characters and strings are also assigned the token literal in most cases, or it could be something more specific, such as character literal or string literal.